All right, guys, we're going to take a look at solving equations. And the first couple of sections are going to be kind of mechanical. Once we learn some of the mechanics of doing some solving, then we'll look at what they mean when we actually look at the graph and we analyze what we've been given. Okay, so first of all, let's just do a little recollection. Okay. In the past, we have so far looked at lines. We have looked at linear equations, which are ax plus b equals c. Or in other words, like a first degree, because it makes a line. Okay? So ax plus b equals 0. We'll put it into general form. Now we're going to take a look, and we've solved some before. We're going to look at some quadratics. If it's quadratic, it's second degree. Ax squared, and then we go alphabetical, plus b times x to the first, plus c. Eventually, even in this book, we'll look at cubic. Well, ax to the third, bx squared. Notice I'm counting down with degrees. Cx to the first, plus d equals 0. And we could keep going. And we will when we get to like later chapters, next quarter. We could keep going. What we're looking at today is we're going to look at some methods for solving quadratics. Okay? To solve quadratics, actually, we can solve quadratics. That's probably a poor sentence there. We can solve quadratics by several methods. The first method we've already looked at. The first method we did in chapter 4. We solved this by factoring. And we've done a lot of those. Then we have a second method, which is called completing the square. And we introduced part of the idea and concept in chapter 6 by using a square root method. We saw that if something was a perfect square, we just took the square root of it. Whatever you did to one side, you did to the other side. And then the third method we're going to be looking at is by using the quadratic formula. We'll do this tomorrow or the next time. These are not the only ways. If we had time, we could use matrices. We could use Cramer's rule. We could use row echelon form. Okay, there's a lot of other ways to solve, but this year we're going to focus on these three. Okay, now factoring sometimes works. Factoring technically always works, but sometimes you can't see the factors easily. If you can't see them easily, these other two methods will always work. Guaranteed 100% of the time. So today we're just going to look at the completing the square method. Well, let's look at the words. Completing the square. This is an action, right? Complete. You have to complete something. It's a verb. When you're completing it, it's implying something's missing, because that's why it says complete the square. So what we're going to do first is we're going to just practice a skill that we've already done before I show you how we're going to use that skill. So let's do this. Okay? Let's do this. Let's practice. I'm going to give you a quadratic. It's actually called a perfect square quadratic. For example, x squared plus 4x plus 4. If I asked you to factor that, okay, well, if we factor this, we would say, what are the factors of 4 that add up to 4? And you would have told me 2 and 2. So because this is a 1, we're done. These are the 2 factors. This would end up being x plus 2, x plus 2, or we could have written this as x plus 2 squared. Let's do it again. I want to start with what you know. That way you're going to recognize that you already know a lot of this based on prior knowledge. Let's say I start with an x squared plus 10x plus 25. Well, what are the factors of 25 that add up to 10? 5 and 5. And again, what we said back in chapter 4 was if this leading variable, if this leading coefficient rather is a 1, then we are done. These are our factors. Or, because they're a perfect square, I could have written them as x plus 5 squared. So perfect square quadratics, when we factor, notice we always end up with perfect factors. They're perfect squares. Okay, now hang on. On the next one, try to figure out what the last number would have to be in order to make it factor perfectly. X squared plus 6x. Well, what would this last number have to be in order for this to factor perfectly? Well, you might say, oh, I can tell what it's going to be because anytime I've always taken half this term and that's what ends up being inside here. So this would be x plus 3 because 3 is half of 6. And if I FOIL this back out, first term's x squared, inside term of 3x, outside term of 3x, that gives us our 6x's. The last term here would have had to have been in 9. So I get 2 identical factors, so I can call them a perfect square. So we're going to use this skill. Notice our leading coefficient is always a 1. Always. Okay? So if it's not a 1, we can either factor it out or we can divide by it. So let's start with this. Find the missing term to complete the square. Again, complete the square. That's a verb. That's an action. It's telling you what to do. They're telling you to complete it. That means something's missing. It must be incomplete. All right. Now I'm going to do this for visual people, and I'm going to also write it out for formulaic, if you like it that way. Let's say I give you x squared plus 14x, and I want you to fill in the blank. I want you to come up with the number that you need to add in order to create 2 identical factors. So some of you may have already seen it's 49. Others are like, wait, how'd you get that? Well, I need 2 identical factors. I'm very visual. So one way to look at this is to go, okay, look, I need to have 2 identical factors. Because that's a 1, the first term in each factor has to be an x in order to get the x squared. Now, if I need 2 identical factors, I'm going to take 14 and I'm going to split it in half. I'm going to take half of 14x, or half of 14. I don't need the x. Sorry about that. I was thinking about something else. Okay, well, if I take half of 14, I get 7. So it's positive 14, so I'm going to get a positive 7, and I'm going to get a positive 7. Now, FOIL this out. Well, your first terms are x times x, done. Your inside term is 7x, your outside term is 7x, that gave us the 14. So your last term, all you ever need is that last term. 7 times 7 is a positive 49. So that's what we would need in order to create perfect factors. Okay? Let's do it again. Let's say I give you x squared minus 12x, and I want you to complete the square. Well, we will always be adding a number, and we'll talk about that in just a moment. Since the first term is a 1, we're done. So I'm going to take and create two identical factors. I have to have an x and x to get the first term. Since they're identical, I'm going to take the negative 12 and I'm going to split it in half. When I take half of that, I get negative 6. Now when I square that, that's a part I didn't do last because that's my last term, negative 6 times negative 6. You will always produce a positive answer. So we are always adding the last term. It's that simple. Take half your middle term and square it. Half your middle term and square it. So if I take half of b, then I'm going to square it. b over 2 squared. All right. Now some of you may be saying, well, that's great. You always chose even numbers. So what do you do if it's odd? All right. Where am I? Number C, or letter C. Well, I've been nagging you about this all year long. Don't change what you know is true. So if I give you x squared minus 5x, and I want you to complete the square, I want you to find the missing term, don't change the concept. Just do the exact same skill. Well, if you like seeing the factors, the first term has to be x and x. Do the exact same thing. Take half of 5. Now some people go, oh, half of 5 is 2.5. Well, now you've introduced decimals. Now you've got to multiply decimals. You can do that if you want. You absolutely perfect. You can do that. What I recommend is don't change what we did before. Half of negative 5, just multiply straight across. Half of something is the same as taking the number and dividing by 2. Half would be negative 5 halves, or divide 5 by 2. I'm going to put half in the first factor, half in the second factor. And now, personally, I think it's easier to multiply 5 halves times 5 halves to get the last term. But if you want to do 2.5 and 2.5, then you're going to get 6.25. No, you're not. You're going to get 2.5, 2.5. Yes, 6.25, and then you're going to have to change that back to a fraction. If you leave it simply as take 5 and divide it by 2 to split it, now multiply 5 halves times 5 halves, and this becomes 25 fourths. This becomes x minus 5 halves squared. Take half your middle term. Well, Mrs. Rainier, what if it's a fraction? Okay. I would probably be asking for a volunteer in class to give me a fraction. Let's be nice for this first one. Let's say the fraction is 2/3. And you need to figure out this last term. Well, again, I like to draw the factors up. I need x and x. Now I need to take half of 2/3. And some of you might go, oh, half of 2/3 is 1/3. Somebody else might say, I don't get it. So over here, I'm literally going to take half of 2/3. 1/3. So that's what I put into each one of these factors, 1/3. Now I take that 1/3 and square it, and that's going to give me 1/9, or FOIL it out, and your last term would be 1/3 times 1/3, which is 1/9. Well, let's do another fraction. Let's do a fraction that doesn't reduce like that. Okay, let's do another one. It's the exact same process. Let's say I give you x squared minus, how about 3/5? And I want you to find the missing term first. Then I'm going to show you why we're going to use this skill and how fabulous it is. How fabulous it is. Because it always works. Always. Well, let's see. First term has to be x and x. Remember, we're always looking for that FOIL idea. So we already guaranteed the first one works. Now, in order to create the two identical factors, I'm going to take half the middle term. Half of -3/5. Well, nothing reduces. Half of this, if nothing reduces, just multiply straight across and get -3/10. So I'm going to put -3/10 here, -3/10 here. If you're not sure that that's half, look, 3/10 plus 3/10 gives us 6/10, which reduces by 2 to 3/5. See, there it is. So I took half, put it in each factor. That guarantees me my inside and my outside will add up to the middle term. So all I need to do is multiply those together. So all I need to do is square or multiply -3/10 times -3/10. Always yields a positive answer, and I get 9/100. So this would factor down to x minus 3/10 squared. Okay, now you've got the mechanical skill. Let me show you how we're going to use it. This is so cool. We are now going to solve quadratics. We've already done by factoring. Now we're going to do it by completing the square root. Okay, let me look at your book. I was going to make up some. No, I'm not going to do that. Not going to do that. Here we go. Let's look at let's look at number 14. Now I'm starting with number 14. I didn't do any examples similar to the ones before that because I will do examples similar to those within the problem number 14. It says solve by completing the square. So we would like to solve x squared minus 4x plus 2 equals 0. Well, you'll notice right now, if I try factoring, do we have factors of 2, which will add up to -4? Well, the answer is no, because the only factors of 2 are 1 and 2. So there's no way they're going to get to 4. So factoring won't work easily. I told you everything can factor, but you can ask me about that during class. So here's what we're going to do. We're going to solve by completing the square. Okay, step 1. And step 1 and 2 are interchangeable, so you could do them in either order. Isolate the variable terms All right. That means I'm going to keep the x's on one side. I'm going to move the 2 to the other side. Step 2. Always guarantee your a value is 1. Well, it is, because our a value, our leading coefficient's 1, right there. It's got to be 1. It is. Step 3. Complete the square. In other words, create a perfect factor. So I'm going to switch colors because this might help. So what I'm going to do is I want to figure out what number I need to add in order to make this a perfect square. So this is what we just practiced. So I'm going to find my 2 factors. If I take half of -4, I need a -2 and a -2 because that's half of -4. So what number do I add to the end when I FOIL it back out? Well, -2 times -2 is +4. Well, you guys have learned since pre-algebra. We learned in chapter 1, properties of equality. Whatever you add to one side of an equation, you have to add to the other side. So if you chose to add 4 to the left, you need to make sure you add 4 to the right. Now, solve for the variable. Solve for x. Well, let's figure it out. On the left side, I have x minus 2 times x minus 2. So that's the same as x minus 2 squared. On the right side, I have 2. Well, this is last chapter. If something is a perfect square, how do you undo a perfect square? You use the square root method by taking the square root. Well, if you choose to put the square root in the problem, we always get 2 answers, positive and negative root 2. When you take a square root of a perfect square, you just get x minus 2. Now bring the 2 to the other side, and we get 2 plus or minus the square roots of 2. We are guaranteed 2 answers because the degree was 2, and we found 2 answers. Or you could have written it as x equals 2 minus the square root of 2 and x equals 2 plus the square root of 2. So you could write it either way. You could use the plus or minus symbol. You can either write it this way or you can write it this way. So we're going to do it again. Let's say I give you number 20. I'm going to change the t's to x's though. X squared plus 8 equals 4x. Well, I know I have 2 answers because it's a second degree equation. We know in the past, we always take the x squared, I'm going to write it in descending order, and set it equal to 0. Now I can solve by completing the square. I'm guaranteed 2 solutions. Isolate the variable terms. X squared minus 4x. Now I need to figure out what number to add. Now whatever I add to one side, I have to add to the other. So I need to figure out what number to add to make this perfect. Okay. Our 2 factors are x and x. half of -4 is -2 and -2. They're not always going to be 2's. And that means the term that we have to add to the end is a +4. Well, -8 plus 4 is -4. So now I have this perfect square equaling -4. How do we solve a perfect square? Square root. Whatever you do to one side, you do to the other. Since you put the radical in the problem, you get a plus or minus. So we now have x minus 2. Well, that's the last chapter. We get plus or minus 2i. And solve for x. Bring the 2 over. And we get 2 plus or minus 2i. Does it always work that way? Yeah. Yeah. Now, somebody's bound to ask, did they give you almost the same thing every time? I'm trying to find one. I'll go ahead and do number 22. Twenty-two says 3n squared plus 12n plus 1 equals 0. Well, again, if you try factoring, factors of 3 that add up to 12 are not going to happen. So I'm going to follow the directions. Isolate the variable terms. Okay, 3n squared plus 12n. So I'm moving the 1 to the other side. Make sure our leading coefficient's a 1. Well, it's not. So what can I do? Whatever I do to one side, I do to the other. I'm dividing by 3 in order to make that leading term a 1n squared. N squared plus 4n equals a fraction. That's okay. No worries. It's just a fraction. Now let's complete the square. Let's figure out what number we need to add to both sides in order to make it work. Make it perfect. Again, your author did this a lot. I need an n times n for the first term. I take half the middle term. Half of +4 is +2. 2 times 2 is a 4. So I've got to add 4 to both sides. Now, you guys, 5th grade math. The only way to combine terms when one of them is a fraction is to have a common denominator. So the common denominator is 3, so I'm going to make this a -1/3, and I'm going to make this 4 times 3 is 12, so 12 thirds. Now I have n plus 2 squared equals 11 thirds. Welcome to last chapter. Take square root. Take the square root. We automatically get a plus or minus. Now we end up with the square root of 11 over the square root of 3. Are we allowed to have a radical in the denominator? No. So we've got to rationalize. So now we're left with n plus 2 plus or minus the square root of 33 over 3. So what does n equal? -2 plus or minus the square root of 33 over 3. And it's better to write this as a single fraction. Now you can leave it that way, or you can have a common denominator and write this as -6 plus or minus root 33 all over 3. I'll take it either way, as 2 separate fractions or as one fraction with a common denominator. And if it's not given to you in those terms, if you have a decimal in the problem, clear the decimal. If you have a fraction in the problem, clear the fraction. We've done those. If on number 32 or 33 you have to distribute first, distribute first. So I'm going to let you, well, I'll take a look at, which one do I want to do? Let's take a look at number 30. We'll finish up with that. Because if you have a fraction in the problem, if your leading coefficient's a fraction, if you have a 1/2 x squared, just multiply by 2. You can always eliminate the fractions first. We've done those. All right, and let's finish up here with number 30. 0.1 x squared minus 0.6 x plus 9 equals 0. Okay, if I isolate the x terms first, now if you don't like decimals, this is 1/10, this is 6/10. You can multiply by the number 10. If you don't see that as just moving the decimal one place, you know, I could move the decimal one place, that'll make it a 1. I could move the decimal one place, that would make it a 6. I'd move the decimal one place, would make it a 90. Or maybe it's easier for you to see this as 1/10 x squared minus 6/10 x. And now you might see why we would multiply by 10. Whatever you do to one side, you do to the other. Multiplying by 10 moves the decimal one place or reduces. Multiplying by 10 moves the decimal one place or reduces. Multiply by 10. And now let's complete the square. Now that we've made sure that that leading coefficient is a 1, now let's figure out what number we need to add to make this perfect. X and x. Half of -6 is -3. -3 times -3 is +9. So that's what we're adding. So I've got to do the same thing on the other side to keep them balanced. So now I have x minus 3 squared is -81. Take the square root. Since you took the square root, you get a plus or minus. Square root of -81 is 9i. So our final answer, bring the 3 to the other side, and I get 3 plus 9i and 3 minus 9i. So I get my 2 solutions. Okay. All right, so I have total confidence. The other ones, we've done something similar in the past. Now you just have a strategy for solving if factoring will not work. All right, so give those a try. Next time we meet, I'll teach you yet another way of solving quadratics. I'll see you next time.